Good morning to our lecturer, Miss Lim Yong-ji. We are from Group 1 and now we like to present about the topic differentiation. My name is HENG and my matrix number is 01 DKM 20F1043 and I from class DKM 2B.
Hi everyone, my name is Lee Hong. My matrix number is 01 DKM20F1070 and I am from DKM2B.
Hi, my name is Muhammad AKMAL LATIFF. My matrix number is 01 DKM20F1073 and I'm from DKM2B.
Introduction of differentiation. Differentiation is used widely in solving problems, especially in engineering, medical, commerce, agriculture, and many other fields. When you find the rate of change of a quantity with respect to another quantity, you are actually doing differentiation. Another name for differentiation is the derivative of the function. Generally, to find the differentiation of y with respect to x, just write the symbol dy over dx to represent it. If y is a function of x, then y equal to fx. The differentiation of y with respect to x dy over dx can be written as f prime x. Therefore, dy over dx equal to f prime x. Stationary points. When the gradient of a point is 0, dy over dx equal to 0. This point is called a stationary point or a turning point. Questions 1. Find the coordinates of the stationary point of y equal to x squared plus 2x plus 3. The solution for questions 1. Step 1. Find the dy over dx. Dy over dx equal to 2x plus 2. At stationary point, dy over dx equal to 0. So 2x plus 2 equal to 0. And 2x equal to minus 2. So x equal to minus 1. Step 2. When x equal to minus 1, so we can insert x into the equation y equal to x squared plus 2x plus 3. So y equal to minus 1 squared plus 2 multiply minus 1 plus 3. So we get y equal to 2. So we get the answer. The stationary point of y equal to x squared plus 2x plus 3 is minus 1, 2.
Thank you Ming Hei. Now we need to proceed to our question 2. For question 2, we need to find the coordinate of the stationary point for the equation y equals to x cubed minus 3 over 2x squared minus 6x plus 10. We also need to determine the nature of the stationary points and sketch a graph of the curve. We take out the equation from the question and start our solution. First, we need to find our dy dx. By differentiate the equation, x cubed will become 3x squared, 3 over 2x squared will become 3x, 6x will become 6, while the 10 will become the 0. Then, at the stationary point, we know that dy over dx will equals to 0. Why? Because dy over dx is same like gradient. As an example, here is the curve, and this curve contains 3 stationary points, which is maximum, minimum, point of inflection. If we draw a straight line pass through these 3 points, the gradient of the straight line will equals to 0. By doing so, we will find the x-coordinate of the stationary point. So, we let 3x squared minus 3x minus 6 equals to 0 simplify the equation by dividing 3 at both sides. We get x squared minus x minus 2 equals to 0, and we factorize the equation, or use the function of calculator EQN to solve the equation. We will get x equals to 2 and x equals to -1. After that, we need to find the y coordinate for the stationary point. How we find it? We only know that x equals to 2 or x equals to -1, and we have the original equation here. So we can just simply sum the x value that we found in the previous slide into the original equation. Like this, when x equals to 2, y will become 0. And when x equals to -1, when we sum the value into the original equation, we will get y equals to 27/2, or equivalent to 13.5. And the coordinate for the stationary point are 2, 0, and another one is -1, 27/2. I shall move on to the next part, which is to determine the nature of the stationary point. How we determine? We need to further differentiate the equation, which is d squared y dx squared, and we will get 6x minus 3. And we sum the value of x that we found into the equation. So, when x equals to 2, d squared y dx squared, we will get the answer of 9, which is greater than 0, and it will become the minimum point for the curve. And when x equals to -1, d squared y dx squared will get -9, which is smaller than 0, and it will become the maximum point for the curve. To summarize that, we have two stationary points in this graph of the curve. One is the maximum point, which is the -1, 27/2. The other one is the minimum point, which is 2, 0. That's it for me, and the next part about the graph will be conducted by my groupmate AKMAL.
Okay, now I will continue our presentation. So for my part, I will explain about graph and its shape. So for this slide, I will explain about shape for the maximum and minimum point. So when we do the second differentiation, if the values we get is negative values, so the values will be the maximum point, and the graph shape will be N shape. So if the values we get from second differentiation is positive values, so the values will be the minimum point. So if the values is minimum point, the shape of graph we will get is U shape. So next, from equation y equal x cubed minus 3/2 x squared minus 6x plus 10, we can find value of x from point x intersection. So to find the value of x1 and x2, we just calculate using calculator. So we can use calculator and change the mode to EQN or equation. So we just key in the values in the equation given. So we will get the value of x1 equal to -2.5 and x2 equal to 2. We also can find the value of y from point y intersection. So to find the value of y, we just use the equation given and we insert x values equal to 0. So the values of y will be 10. Okay, now we go through to the graph. So from the equation given, I use Desmos that I search in Google to create the online graph. So in the Desmos, I just need to type the equation to create the graph. If we look to the graph we get is the cubic graph. So the maximum point in the graph is in coordinate -1 and 13.5, and the minimum point is in coordinate 2 and 0. We also can identify and see that 2 points, the intersection of S, that I tell you just now. Okay, this slide is about graph explanation. So from the graph above, we can conclude that the equation y equals x cubed minus 3 over 2x squared minus 6x plus 10 will bring us to cubic graph. Next, we can see from the graph there are two intersection points on x-axis and 1 point on y-axis. Next, we also can get the values of x from point intersection on x-axis by keying the values from equation to the calculator using equation mode. Next, unlike the x values, to find the value of y, we must insert the value of x equal to 0 in the equations. And the last, from the graph, we also can identify the maximum point in the graph is in coordinate -1 and 13.5, and minimum point in the graph is in coordinate 2 and 0. Okay, next, this is the application of differentiation in real world. There are many applications of differentiation in real world, but I will highlight one example for you. As we can see, this picture shows us the roller coaster. The engineer will use the differentiation to calculate the maximum and minimum point of the railways. Okay, now we can go for the conclusions. Okay, now for the conclusion, we can relate derivative in our life because there is many fields use the derivative, such as physics, biology, chemistry, economics, business, and others. Differentiation is the part of a calculus that was developed to improve this understanding. But we can just focus in our field. In engineering field, derivative can help us to solve many types of real-world problems. We use the derivative to determine the maximum and minimum values of particular function. For example, mechanical engineer will use the derivative to determine the behavior of moving objects to solve the problems. From this presentation, our group members can more understand about the differentiation topic. Credit should give to our lecturer that teaching us wisely. That's all for this presentation. Thank you.